Hello everyone, this is Anirban. I'm the Business Development Director at Red Hat for cloud platforms in the Asia Pacific region. For those of you who joined us for the first part of this webinar on the 2nd of July, you would have heard me talk about Red Hat Migration Analytics. We demonstrated how this tool can help you identify immediate opportunities for cost savings within your IT organization by migrating to open source technologies. In today's session, we will provide a short recap, which will hopefully jog your memory and serve as a brief synopsis for those who are joining us for the first time. Then we will move to the main part of the presentation that will cover creating business case for migrating and modernizing applications. As we return back to work after the COVID-19 pandemic, business leaders will be compelled to transform their organization at a pace we have never seen before. Your companies will most likely want technology to be extremely lean, nimble, and agile to cope with future business disruptions such as this one, and at the same time, well suited to seize the market opportunities that presents itself in the post-COVID era. The next few years are likely going to be a balancing act. On the one side, IT will have the mandate to reduce cost and maximize workforce productivity. While on the other hand, businesses will want to know how IT is innovating and steadily acquiring new capabilities that help the company seize opportunities in a digital world. There is no doubt IT organization will want to accelerate their cloud journey. But as you do so, you will most likely want to focus on migrating and modernizing existing legacy applications to be cloud native so that you're ready to take full advantage of the move to public, or in many cases, hybrid cloud. If we look at this in a logical way, IT organizations will first and foremost need to draw a plan to save costs. As we saw in the last webinar, Red Hat Migration Analytics can help analyze your environment to identify potential opportunities for cost savings by adopting open source technologies. And at the same time, utilizing automation can increase the overall productivity of your workforce. The steps you take in optimization and automation will deliver tangible cost savings that your business wants. Then you can reinvest this to fund innovation that your business needs while you go through your journey to cloud. In the last webinar, we demonstrated how Red Hat Migration Analytics automatically discovers the infrastructure and applications in your environment and then provides detailed reports on the following: savings estimations to help create a business case, workload migration summary to help identify risk and set the approach for migration, workload migration inventory to help plan the migration process. In today's presentation, we will discuss how you can plan the future by creating a business case for cloud native migration. According to leading management consultant McKinsey, companies often fall into the trap of confusing simply moving IT systems to the cloud with the transformational strategy needed to get full value of cloud. Just taking legacy applications and moving them to the cloud, also known as lift and shift, will not automatically yield the benefits that cloud infrastructure and systems can provide. In fact, in some cases, that approach can result in IT architectures that are more complex, cumbersome, and costly than before. The full value of cloud comes from approaching the journey to cloud as part of a holistic strategy to modernize applications in order to make them capable of cloud-native deployments. Traditional monolithic applications usually have a single code base where all functionalities exists. Cloud-native applications, on the other hand, are characterized by modularized, autonomous, loosely coupled microservices that work together to deliver business functionality. They are usually built and run on platform as a service using containers with DevOps practices enabling continuous delivery. As a result, cloud-native applications are many times faster and it is much easier to implement new features. Making changes means tweaking a single service and deploying it independently rather than deploying the entire application. Because of these critical benefits, businesses are developing almost all new applications as cloud native. Regrettably, however, the vast majority of enterprises are still running legacy systems, and most industry experts are recommending that organizations should immediately create the business case for application modernization. Because as time passes by, the technical debt increases and it becomes increasingly harder to keep up with competitors who are far more agile in capitalizing the opportunities in a digital world. According to Capgemini's research, 88% of the customers said adopting cloud native improved their business agility. 84% were able to increase revenue and reduced operating cost. 87% said cloud native adoption enabled them to provide enhanced experience for their customers. The harsh reality is that modernizing legacy applications is actually extremely hard. Most organizations start with aggressive goals, but are often not able to achieve their objectives. Progress may be hindered by technological challenges, varying priorities within teams, unavailability of the right skills, the cost of change, lack of leadership, and for many other reasons. Unfortunately, as time passes by, organizations accumulate more technical debt, and that makes it even harder to make the change in the future. First, let's dig a little deeper into the technology challenges. Perhaps a good place to start is the official definition of cloud native, as defined by the organization CNCF, or Cloud Native Computing Foundation. So according to CNCF, cloud native technologies empower organizations to build and run scalable applications in modern, dynamic environments such as public, private, and hybrid clouds. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. It becomes apparent from the definition that technologies such as microservices, containers, service mesh, CI/CD pipelines enables loosely coupled systems that are resilient, manageable, and observable. Combined with robust automation, they allow engineers to make high-impact changes frequently and predictably with minimal effort and risk. One of the biggest hurdles on the technology front can be attributed to the effort required in integrating numerous open source projects required to deliver all the capabilities described above. It is even bigger challenge to secure such a platform, certify and support it for a variety of custom developed and ISV workloads on various on-premise infrastructure and public clouds. In order to solve the technology platform challenge, Red Hat has built OpenShift with the philosophy of delivering a comprehensive cloud-native application platform that caters to all the needs of enterprise customers. OpenShift is secured and tested to interoperate with various technologies that are commonly needed for developing and running cloud-native applications, and it is delivered as a single supported package. At the heart of OpenShift is the highly secured and robust Red Hat Enterprise Linux operating system. Since containers are nothing but Linux processes, it is a critical component of the next generation platform. Workloads running on OpenShift are seamlessly portable across physical, virtual, private, and all major public clouds. Kubernetes acts as the container orchestrator, while Red Hat makes it easy to manage the lifecycle of the cluster via over-the-air updates, monitoring, logging, self-service portals, chargeback, etc., which are all integrated in the platform to simplify operations. OpenShift platform has built-in capabilities for service mesh, CI/CD pipelines, serverless that can all be leveraged by cloud-native applications. Leading programming languages, runtimes, automation software, integration software, databases, message queues, and hundreds of ISVs are fully certified and ready to be deployed. OpenShift offers flexibility to developers so that they can be most productive using the tools of. While OpenShift can certainly solve most of the technology platform challenges, the success of application modernization needs the support of various stakeholders to make sustainable changes to the organization required in order to deliver the desired business. Red Hat recommends taking an incremental approach based on thorough analysis of your application landscape, mapping the effort and risk involved in each migration versus the potential business value. The first step involves a detailed assessment of the application landscape across the organization. The results are coupled with an understanding of organizational capabilities to set the direction for each application. All this is then layered with the potential business value of modernizing the application to cloud native in order to finally create a business case and identify a priority target list for migration. This is obviously an iterative process, which is expected to shorten in time and effort for each subsequent modernization project, as the organization incrementally gains new skills and capabilities. Moving to cloud native invariably means making fundamental changes to the IT organization and its processes. This may affect several domains such as operations, security, networking, and many others, as applications are increasingly migrated to hybrid and public clouds. Almost all parts of IT organization need to be involved when trying to move traditional waterfall model to DevOps best practices using containers and microservices. The success of a modernization and migration project is dependent on organizations' capabilities. Key areas to review are technology and processes that are in place. What is the expected business impact versus the potential risk of such a migration? Which application should be prioritized? This is obviously based on business value and other organizational objectives, while being fully cognizant of the effort and risk involved. The IT industry uses this popular representation of 6 R's to define the various strategies that can be adopted for typical cloud migration and application modernization projects. Each R here denotes a certain treatment for the existing application before it is migrated to cloud native. In today's discussion, we will focus on the top 4: rehosting applications to a new cloud native platform such as OpenShift, replatforming, re-architecting, and refactoring to take advantage of cloud-native capabilities such as containers, microservices, and APIs to build loosely coupled, resilient systems. In just a few moments, my colleagues will demonstrate 2 tools that are available free of charge to Red Hat customers to help you assess your existing applications and create a business case for modernizing them by replatforming to cloud-native container platform like OpenShift. Potentially refactoring to microservices, re-architecting them to use service mesh or exposing APIs, as well as various other cloud-native capabilities such that the engineers can make high-impact changes frequently and predictably with minimal effort and risk, dynamically across public, private, and hybrid clouds. During the last webinar, we demonstrated migration analytics that collects inventory of all infrastructure and applications to identify immediate opportunities for cost saving by migrating virtualized IT infrastructure to open source technologies. The next step before embarking on an application modernization project is to assess your organizational readiness. Red Hat offers a tool called Ready to Innovate and Red DevOps Scorecard that benchmarks against industry peers to assess current organizational readiness. This is followed by Pathfinder assessment that we will shortly demonstrate to assess the technical readiness of application to run on containers. And finally, using the Red Hat Migration Toolkit, these results are analyzed together with deep analysis of application source code and its dependencies to identify potential risk and effort involved in migration. First, let's look at a demo for Pathfinder. which is based on a simple questionnaire to assess your application and determine if they are the right fit for containerization. Over to you, Miguel, for the demo.
Hello everyone, this is Miguel Perez Colino. Let me give you a quick overview on Pathfinder. Pathfinder is a tool that you can see here that is running right now on OpenShift that could help you understand better your applications. So first, we could create just one account here. I have one prepared for you. And in this account, we can just add applications, right? So we have some applications that we have reviewed, but let's check how we can add a new application. So I added this application. Okay, let me remove it and re-add it. Okay, so we add a new application, we give it a name. In this case, I call it Teruel. Okay, type is an accessible application. We can add applications that are only dependencies. I have several like databases or LDAP servers. So this is an accessible application, something we're going to assess. So, and we give a description. And of course, the owner. Okay, so in this case, let's say it's Mr. Doe is the owner of this application. So we're going to assess this application. First, we create an entry for the application, and then we click on Assessed. And then we'll go to the assessment. What Pathfinder does in the applications is review the status of the context of the application, the environment, how are we treating it, how are we reviewing it. So this is a questionnaire based that can help you understand how containerizable are our applications. So in this case, let's say that does the application team understand actively and develop the applications? Let's review the questions as you see. So this application is being actively developed and there's a subject matter expert. So we're good. Then what else? How is the application supported in production? We check the production environment. In this case, let's say that we have Azure is. I mean, maybe sometimes we have a third-party team that is managing it. Sometimes we don't know it, and we click on unknown. So we can keep going. Okay, how long does it take from the moment the code is committed to the moment that the application is on stage and in production ready? So in this case, let's say that it's between 1 day and a week. So this shows how the application is treated, how many steps and how long the steps take from the application to go to production. The deployment frequency, let's say we're weekly deployments. The mean time to recovery, between 1 day and an hour. And the legal compliance requirement. This is very important because sometimes for compliance we need a specific cluster. So let's say that we don't have any legal compliance requirements. And the application architecture. So in this case, it's let's say a massive monolith. No, a complex monolith. So depending on how you're building it, it's more easy or less easy to decompose this application and bring it into into microservices. And in this case, we're going for the complex monolith. We can add any comments on this chapter. So we go to next chapter. We have different chapters. This is about if we need any hardware requirement. I mean, we only need a supported CPU and we're using standard Linux. I mean, sometimes we have applications that are running on Solaris and require a specific CPU to run it on because it's not Solaris for x86. And we have to take that into account, okay? So what else? Components, no third-party components in this case. If we are using third-party components, we'll need them to be supported and certified as images to make it easier to bring into containers. We can go to the dependencies. Okay, this has some internal dependencies, okay? And it's depending on the application Leon depends on this one, okay? And also the application Avila depends on this one. So we can check if some applications depend on others and give some dependency mapping. Again, also, this application will depend, for example, on a database and LDAP. So we can say, okay, we need to check that the database Bilbao and the LDAP Madrid are ready before this one starts. So we can go ahead and keep checking on the assessment. So we are doing we employ some architecture patterns to avoid outages and restarts. If we don't use that, it could be more complicated. and then how the application connects. I mean, if we are using like old school protocols such as IPX or AppleTag, it could be an issue. But if we are using plain HTTP traffic or HTTPS web traffic, it would be much better. So we keep assessing the application about the external state. For example, we are the application is stateless. That is wonderful for containers, but we could make it shared or non-shared, maintain ephemeral storage. So we keep assessing this. The DNS, okay, just standard DNS resolution would work, and how the application is clustered. Oh, it uses its own internal mechanism that is suitable for scale out. So we keep doing this. Now login. How do we do login? Well, we use syslog. We are pretty standard. And we use metrics via SNMP. And then traffic. Okay, we have liveliness. In Kubernetes, we have some props for the application to know if it's ready. So if we have already props for it, it will be great. So we have, for example, some independent endpoints for liveliness and readiness. In this case, let's say. And then we go for about CPU usage. So in this case, let's say we have intermittent traffic. And how does it take? How long does it take to the application to be handled the traffic? This is important for horizontal scaling. If you add new components, new pods to your application that are running and they are listening, how long does it take? Okay, so if it's less than 10 seconds, we're good. But if it's more, we need to address it. Let's go next. Okay, testing, and we're finishing. We do some automated testing. How the application is configured. We are loading the configuration files from a place. Are we using credentials, certificates? Yes, and we load it via files, so they're not embedded in the application or anything, so we can provide it. How is the application currently deployed? Maybe we have CI/CD pipeline. If it's manually done, I mean, we'll have to take into account that this will require to be automated. Where is it running? Well, is it running on right now? It's on VMs on OpenStack. Okay, and how mature is it when it comes to containerization? Okay, well, we have some experience with containers. We have tried it, but it's not fully done. So as you see, we are reviewing all the context around the application and how the application is being handled. And now, once it is reviewed, we can have someone from Red Hat Consulting that it could check and review the assessment. And then it's like, okay, we have reviewed it with you. What is the proposed action for this? Okay, let's refactor it. It's a very well built application, so the effort to refactor it will be medium. This application is not so critical, but we wanted to have it early, so we have a high priority for it. Let's give it a 10. Okay, and then we can check here all the questions that we have, which ones are red, green, or amber, like a traffic light, to see which ones could be an issue. In this case, it's a pretty straightforward application, so we can submit a review and we could add notes to it. And you see we have all these applications that have been assessed and reviewed. Okay, we have these many applications. Sometimes if you leave a question as unknown, it will stay here just in case you want to edit it and change it. So I could go and edit this one. I'm not going to do it right now. Let's go back. So we have all these applications. They have been assessed, they have been reviewed, they have the criticality, we have the decision that we have made for it, and then we can take the application one by one and take a look at, what are the issues. In this case, for example, this application has more red issues, like the deployment frequency that is not checked, or for example, how it is communicates between with other applications, which is an IP encapsulated payload and is based on hostname. So in this case, as you see, we have some reds. This is a pretty difficult application to migrate. So, and then it's like, okay, we have a review of every one of the applications, and now I want to be an overview, so I can get a report on the status. So we have 4 applications that are almost cloud native ready, that we could take them to containers very easily. 6 applications that we found modernizable, and 6 applications that would be very difficult to containerize. I mean, normally we wouldn't say unsuitable. We have found that many applications that even we say they are not suitable for containers. I mean, it take more effort, but they could be containerized. And then we can see this map here, in which we see the distribution, seeing the impact. You see which ones on the right side are impactful, and then migration, the business criticality, impactful on the vertical line, on the horizontal line, the confidence, how migratable are they? So the ones on the top right corner are the ones that are very impactful and migratable. The ones on the left down corner are the ones that are like, okay, these are unadvisable, or you need to review them. So in some cases, you have to think about starting a new application or even retire them. So on top of that, we have a suggested adoption plan based on the effort that we have said, and being able to do it based on the priorities and the identified risks. In this case, we don't have a list of identified risks, and of course we can see who are the members in this case and check it all. So what does Pathfinder do for you? It helps you review the application. It helps you review the status of them. It helps you have a full picture on how migratable these applications are, and it helps you have someone from Red Hat Consulting review them with you and be able to have a full assessment on where to start in your journey to containers, in your journey to Open Hybrid Cloud. Thank you very much.
Thanks a lot, Miguel, for that detailed demonstration. Now, let me hand over to my colleague Jafar, who will demonstrate the Red Hat Application Migration Toolkit. The purpose of this toolkit is to carry out a deep analysis of the application source code to identify potential technical risks so that it can be stacked against the expected business value from those applications.
Jafar, and today I will be walking you through the Red Hat Application Migration Toolkit, which is a tool that allows you to easily analyze your existing application in order to migrate them to several targets. So for instance, we will create a migration project that we will call APAC migration, for instance. And all I have to do here is select a list of applications. So for this demo, I will be using only one for the sake of time. And as you can see here, we have several targets. So we can analyze the application for migrating to JBoss EAP 6 or 7. We can analyze the application to see if it's fit for containerization, or in order to migrate to Linux, or if we wanted to port an existing Java application to the Red Hat distribution of OpenJDK. And so as you can see here within this section, we already have introspected the application and found out some packages. So we can specifically pick which packages we want to analyze or exclude within the analysis. If we wanted, we could also create some custom rules, but we will get back to that a little bit later. So let's just go ahead and launch the analysis. And this analysis should actually take about 40 seconds to complete. And what is currently happening is that the tool provides you with an existing set of analysis rules to introspect the application components to see what classes are being used and see if they are compatible with the target that you are selecting. So as you can see here, it is currently executing almost 1,400 rules to analyze the application, and the results of that will be available as a report that we can go through. So let's go ahead and click through it. So we can see here that we have some labels that say if the specific target is supported, partially supported, or unsuitable. So for instance, if we wanted to migrate to JBoss EAP, there are several packages or components that are not compatible, and there are other ones that are green, meaning that it's all good to go. So let's dig into more details for this application. So this overall dashboard gives us an understanding of the complexity of migrating this application. So it creates several issues and creates story points for all of these issues to explain the complexity of addressing each one of these. So we can see in here the distribution of issues in the packages. So we can see that this package takes a lot of the migration effort. So that's probably something that we need to address at first. It also tells you if there are some mandatory issues that you need to address. So this is the bare minimum that you need to address in order to be able to migrate the application. Now let's have a look at those issues and see what kind of help the tool actually provides. So let's pick this one for instance. This incident says that the application is actually using the Webflow proprietary logger, and if we wanted to migrate to JBoss EAP, we should use a more Java standard logging class, and it also suggests what actually is the solution, the suggested solution to address that issue. So the way it is done is it actually matches a set of rules, and as we can see here, it says if you find this classes, then this is the solution that should be provided. And as I mentioned, this is part of the 1,000 rules that we provide out of the box, so you don't have to actually create your own. But if you wanted, you could create a custom list of rules to extend the analysis possibilities. Now let's look at the application distribution. We can see the story points for each of the issues, and we can have a bit more detail about each of them. But if we wanted a broader understanding of the technologies used by the applications and analyze which ones we should be migrating first, we have a good understanding of that with this dashboard. For instance, we see that the application is using EJBs, it's using messaging technologies by using JMS queues. So that gives you a good understanding of all the technology components and its distribution across all the applications that are being analyzed. We can also provide you with the analysis of the dependencies of the application that you can see in this page, or you could also visualize it graphically. So this is representing the application and its dependencies are gravitating around it. Again, let's see a bit more details about the EJBs for instance. Here we can even have access to the implementation to browse the code and actually see where we need to make the changes. And as you can see, this is being highlighted in here. So it gives us clear indications of where we should look into making changes. So that's it for today. I hope it gives you a good understanding of what this tool provides, and hope you enjoyed it. Thank you.
Thanks a lot, Jafar. We have covered a lot of content today, but as you can clearly see, Red Hat can help you in multiple ways on your journey to the cloud. We reckon building the business case for modernizing legacy applications to cloud native is often the first step to gain buy-in from key stakeholders. This can pave the way for further discussions on how Red Hat can partner with your organization. You will shortly receive a follow-up email with links to this presentation and additional information that further elaborate on the approach that we have recommended today. You can also contact Red Hat sales team or our channel partners if you are interested in more information or wish to engage in any of these free assessments that we discussed today. So looking forward to hearing from you. Thanks a lot for attending, and now we will open for questions.